I will start the session with my presentation from Discovery Summit, and I think here I will go more in detail. I've presented this in March in Manchester, Data Cockpit. I will not go through all the through all the company slides. I will start here. The background of my presentation, I hope you can see the full screen well. The background is that we have a complex manufacturing structure and complex data sets. And we need to be able to pull out in a flexible way different data and need for solutions for that. And that's why I set up a problem or a task. So the wish was to have one data table, I call it Cockpit, that contains an overview on products or batches, and that we have some overview graphs to assess some performance and other parameters, that we can gather other additional tables that are generated based on content or selection of the main table of the Cockpit, that we can add additional columns as needed, that we can provide links for drill down. And I did not write an application like a graphical user interface with JMP application builder. I just thought that the JMP data table is already a great graphical user interface for doing so. So the solution steps are, I use database queries with new SQL query objects a lot. I use JMP data table for as interface for the user. The background is that the users are JMP users. They have the application JMP and they can work with the data table. I use the event handler to act on click, and I use a lot of table scripts for starting platforms, for adding columns, for generate detail tables, or to do everything in one click. And in this presentation, I will not work with company data, but we can work with a sample data table, and that is anodic bond. And we use almost the same script, because the new SQL query as well works on JMP data tables as it works on databases. So in the real application, the data comes from company database. The summary table may be compiled of a lot of different tables. Additional data is added. Other sources could be used as well, like written here. In my case, I mainly use database queries because most of the data is in the database. And in this presentation, I only use one table of JMP sample data, but the access is very similar to access databases. And this is the content of the table anodic bond. So we have several continuous curves here for several parameters like charge, flow, force, vacuum, voltage. 5 variables along order, and additionally some summary data is generated. So this is how the cockpit looks like, and we will see it later in JMP. So there is a wafer ID and some assessment of the wafer, whether it's good or bad. And I will show all these things, how it works, and you can download it as well and try on your own how it works. It should run on your system as well without problems, hopefully. And as you can see here, I have grouped the scripts and grouped some columns And with full functions, the cockpit may look like this. So we have several scripts here grouped. We have here an event handler. We have graphs, inline graphs in the data table. We have additional platforms or graphs, and we have a symbolic link here. Yes, and this is the point I will switch over to JMP. I have JMP 18 already, and this is the data cockpit. And at first I have here two scripts that show me some information, because I thought when the user had this data table, there may be well-placed in information what we are talking about here and how it is to use. And here you can find the link to the community. You will find it in the Scripters Club as well. And here you can download the presentation I have shown and the JMP data table with all the functions I will show working. And I have tried to build, let's say, a journal by scripting. I think I didn't do it very well. You can see here, I make it a little larger. It's just I placed in a new window a little text, and I'm still seeking for a way to produce a journal by scripting. Perhaps somebody in the audience has an idea how to do this. This is one way. This produces this window. Okay, and another way, maybe this one, not looking very nice. And here I try to explain the functionality, and I put in the text in an associative array like this, with the heading as a key and the text here. Was just an idea. I had no better solution at that time. But it's possible to produce, let's say, a window out of a lot of text. So let's have a look at the cockpit in detail. So under database, I have grouped the scripts. There is a script that clears the table. I need it for some reason. And there is a script that updates the cockpit. So puts the main data into the cockpit. Maybe first we should have a look at the full database. I have this script here that opens the sample data table. And the sample data table anodic bond looks like this. And I produce all of the content in my cockpit out of this table. So you see we have several wafer IDs here, like 2000 wafer IDs and 60 values for each wafer ID. The wafer ID with a condition, good or bad. And you can see these curves here for each wafer ID. For the charge, for the flow, for the force, for the vacuum, for the voltage. And for each curve, just for demonstration, I pulled out a characteristic position. Let's say for charge, it was the number 43 that may be characteristic for that wafer. For the flow, it was position 40. It's just determined by me. For force, it is position 30, vacuum position 3, and voltage position 27. So this is the structure of the data and how to produce this. Let's have a look into the script. So first, in this case, I need to open or I do not really have to open the data table. Here it opens the data table and puts in some script to the data table to generate that graphs we have seen now. And that's all. I just place in that script and run that script. Okay, close it here. Now we have a picture of the data that is based here. Let's have a look at the Cockpit, update Cockpit, how this is generated. So it's a small script and it has the new SQL query. And the target of the query is a jump table. In the case of a database query, we would have a connection like a ODBC here. But here I put the query, it is a custom SQL query, to this jump sample data table. And here I have the custom SQL in quotes. And when I used quotes within that SQL select, I have to escape them with this backslash and exclamation mark. Later, I will show a better way to do this. And here I just pull out all the data out of the sample data table with the limit. So I only pull out the wafers from 9070 ID up to 2000, so only 30 wafers. So this query is run, and when the run is complete, I close the sample data table because jump in this case has opened the sample data table and I do not need it. I only want to have the data. And I delete some scripts like I do here. This is done triggered by onRunComplete. And this updates the current data table. So the data we have pulled out is pushed into the current data table. And this script works like we can see here. If we clear it, we get the result. Clear table is needed. Let's have a look how this works. So I delete all rows in the data table and I delete additional columns with a try to get not an error if this is not there. So in this case, I would not have the graph vacuum. And I delete all detail columns that are not available here now as well with this command. So we will see later how this works. And I remove the link property. Okay, next script would be run all to have a picture of what the full functionality is. Let's do it. So run all pulls out all the data. It takes a few seconds. Now everything is there. And we get the full data table with these aggregated columns and these detail columns, and with the graphs in that table, inline graphs. The graphs are of type expression. You can see here of type expression, and I will show later how this is generated. And having this updated cockpit, we may have a look at some summary data like this. So it's just one parameter like charge maximum versus wafer ID. And because I have set the graph to be a label, I will see the graph out of the table here as a label. It's just one option if needed. Could be done like this. And we can go through all the parameters defined here, let's say by a column switcher. How is this done? So it's quite easy. I have just made a graph builder via Analyze Graph Builder and copied that script into the scripting editor. And yes, that's it. Like you can see here. We can do other things like one-way analysis to see the assessment good, bad by different parameters, or to do a predictor screening like this. So here we have the predictor screening for condition, good, bad, and what determines this result. And here it is a little different. I have written this like you can see here. I have added the aggregated parameters and the column group details. So if we have changes here, if I add additional details, I reference them via the column group and JMP gets them all. And this script is as well working without the details. So if we would have only the aggregated data without details, the script would run without an issue. Like we can see here, if I clear the table again, update cockpit without details, and now do the predictor screening, it is without the detail. So it's quite flexible to work with column groups and to reference them via column groups. Okay. With the full update, other tables and graphs has been generated as well. Like you can see here. So this is a cockpit. This is my JMP window. And I have some flow details here with the table. This is the image. There is nothing special more in it. It just has been generated as a detail table with a graph. And it works. I will close it like I will show here. First close this one. Yes, let's go to the details. I will show later how this works. So the details for wafer ID. If I press here to start the script, it's just a reminder to click on a wafer ID. And you can see here is a link behind. And this link pulls out all the detailed information out of database or our sample table for this ID. So for wafer ID 1971, we get all the data, and here is a script placed in to show the detail curve of this one. How does this work? So the link here is generated via the event handler. So the event handler, you can add an event handler, and it offers you a web link depending on the, let's see whether I get it here. Let's say I make a new column here with a web page. Out of the box, you can generate an event handler here. That puts the content of that cell into the command web. I press OK, and now it's a valid link. And if I press it, I get my browser opened with that address. So this is what is working out of the box with JMP. And in my example here, I have modified the script behind the event handler in a way that it opens the new SQL query object. Target of the query is the JMP sample data table, and it is a custom SQL query with this text. And here I have a different way. I used this backslash square bracket. That's because I do not need to escape the double quotes in here. It's a different type of a string. And I use eval insert to replace as a condition for the wafer ID the content of the current cell. This is the content of the current cell, and I make it to be a character. And this is inserted into the query. And on run complete, I say close the data table, delete the scripts because I do not need the scripts that are in that sample data table, and add my scripts like charge versus order with the graph builder you have seen before. And that's all. So that makes my link in wafer ID working like shown before. So if I press 1973, I get all the details of the wafer ID 1973 out of this table. You can again see the query that I have put into the new SQL query object. And here you see the right ID. So this is how the event handler works. Next one is details of selected rows. So if I have not selected any row, you can see here, and I press here, I get a message, please select rows. OK. And if I select, let's say, row 3 to 6, 4 rows selected, I get some details on these selected rows. And in this case, it is a graph of these 3 wafer IDs. If I have a look at my JMP main window, I can see that I have a graph and a data table behind that is hidden. And if I close the graph, the data table has gone as well. So this element works like follows. I edit the script and let's see, we make it a little larger. It first pulls out a wafer list of the selected rows. So here I get the wafer IDs of the selected rows. This gives the number of rows that are selected. If are non-selected, it gives us the message we have seen and stops everything. If something is selected, I make out of the wafer list, that is an array, I think, a character, and I substitute the square brackets to round brackets to get that string that I can put into the SQL query. Then I define that SQL query, set up the data table I need, and insert this list as type character into the SQL via eval insert. And again, on run complete, I close that table, close all the scripts in the table, and hide the window. Show window is set to 0. And then I add to that table that has been generated a new script, vacuum versus order, like this. I have generated this script via Graph Builder. I run that script and I set on close. So when data table is closed, when the script is closed, when the graph is closed, then this command is executed, and this command closes the data table behind and does not save anything. Okay. I close it. Details for selected rows. Yes, now we have this. Now we come to how the detailed columns are added. I can delete this column and let's make the window large. This adds additional details, like shown before, at certain positions, so single values. Edit this script, and when writing scripts, I think a lot about how to store the information I need. And in this case, I have chosen a list of associative arrays for storing the information I need later in the script. And a list is a good thing to loop over. And I use a lot of loops here. The script is not very large, like you can see here. We have only 54 rows, and here I have defined an ID for each parameter. This is the name of the column in the cockpit, and I have defined a name in the query, that is charge in the anodic bond data table, and a value that I need as condition. And first, I create the columns if they are not existing. So this works with existing and non-existing detail columns. And I can use this list already to do so. So the columns are generated here when they are not available so far. The next step then is that I group that columns. So I group all these detail columns in the column group details. You have seen this here. It makes it easier later to work with all the details. And then I start to query all the detail. So I go through that list with the associative arrays. And one associative array is a detail. I show the ID for debugging issues. And then I build that query object, and I get a detail data table out of it. And in that query, I put a custom SQL where, as a condition, the detail ID is used here, detail ID. Now it's like this. The condition is where, here is it, where this is the condition, the 41 we had here, or 43, is this order is given that value, and the names are set here, again via eval insert. So in eval insert pastes the details here into the query. And again, tables are deleted and so. And then I use, with that detail data table, I use the update. So update with the detail data table, I update the cockpit, and I replace the column with the detail ID. So this one. It's quite complex. It took me some runs to put the script like it is now, but I think it's an efficient way to get in all these details, and it is flexible that in a way that we can, let's say, simply here, I don't know if this works. Maybe I will try to put this in a new script window. I copy everything. I start with clear table, update cockpit. Control T gives me a new script. And let's have a look into this. So if I do so, we can see here for debugging issues, we see the shown detail names. The values are added. And if I want to add additional value, I can simply extend this. Let's say we want voltage 40, voltage 40. Let's have a look whether this works. This does not work because, yes, I made something wrong. I missed a colon here. Let's use Control M to reformat, then I can see if there is a syntax error, but it does not look nice anymore. But let's try if it works now. And now it works. So just adding an element to that list gives me a new detail value. Let's close this again, clear the data table, update Cockpit, and we have seen how the details are updated. Let's have a look how the inline graph works. So if I press this script and make it a little larger, then we see that all these graphs are generated. I have reduced this table to 30 rows because the generation of the graphs may take a lot of time. Have a look at this script. It's simply the same as you have seen before. Here it's different because the column is of type expression, and I set it to be a label. You can see it here. This is expression type, and this is a label. And then I say begin data update to have not the data table interface refreshing every row. It makes the script faster. And then I go through all the rows of the data table. I have restricted here additionally to do only 100 rows because it may take a lot of time when having thousands of rows in a data table. And for each row, I again start a query that puts in the wafer ID as a condition for the wafer ID. It is this wafer ID, you know already, and pulls the data out of the sample data table. On run complete, again the same. And then a graph builder is generated on the detail table that is generated for every row. For every wafer ID, we generate a table with a graph builder. And I say the graph builder not to be shown via show window 0. And then I take the report layer from the graph builder. I pull out the picture, and the picture I assign to that row, graph vacuum, for each row. So it's this loop makes available this column here as a single cell. So here the graph is assigned to that single cell. Then I close the window and close the data table. This is how it works, and I set the cell height to 200 that the graph can be shown. If it's smaller, you cannot see the details. Okay. That's regarding the graph vacuum. Missing now are only some details that are quite easy. So here I simply generate the details of charge for all IDs. So again, I pull out all the wafer IDs, put it into the query, generate a table, and generate a graph. And simply run a script I have added to the table before. Let's see how this works. Pressing run, it makes a table and the graph. There is nothing more in it. It's the same for flow. Okay, this is all of the functionality in this data table currently. Sometimes I think it's not nice to have all the windows generated here, and it would be great to have it within a project, and we can do this as well. A few things change when working in a project, but here is a script that simply places this data table into a project. We will see how this looks and how it can be done. So I press this. It's on a different screen. Here we have it. Now we are in a project. You can see it here. We have a workspace and here the data table. And the script we have had before are still working. So we can clear the data table, update the cockpit. And if we would generate a graph, for example, here it is generated as a new tab within the project. It may be nice, but not everyone likes project. And we can have a look how this is done. It's quite easy to put a data table into a project. So here I simply define a new project and save it in the temporary directory. And then I move the current data table that we are in here with that script into the project. That's all. And in the project, maybe I do not need this window. I can close it by a command like this, edit, and here I simply say to the project that contents, bookmarks, and so on should not be shown. Okay, I think that's everything I wanted to show at the moment, and I think as well there is still a few time left for discussion. If there are any additional question, maybe Mauro, you can take over